Take a look at this reaction where I have my Grignard reagent reacting with the carbonyl, forming a new carbon-carbon bond right over here and giving me this negatively charged product. Now, look at this reaction, where my Grignard reagent reacting with the carbonyl, making a new carbon-carbon bond, giving me, well, exactly the same negatively charged product. In both cases, I have tetrahydrofuran as my solvent as well. So what is the difference between these two reactions? And the difference here is, well, none. There is no difference between these two reactions. Hey everyone, Victor is here, your organic chemistry tutor, and today I want to talk about 5 most common misconceptions about the organic reactions and reaction schemes. And the first misconception that I see a lot of students holding on to dearly is that the reagents in a scheme have predefined position. Well, that is simply not true. We write our reactions and we write our reaction schemes the way it is more convenient for us. Typically, the place before the arrow, we are going to designate that place for our substrate. What exactly is a substrate? Well, depends on the reaction that we are doing and depends what we are going to look at as a substrate. Often, above the arrow over here, we are going to show our reagent. Again, it depends on how we are doing our reaction and how we're going to be looking at that. In my first case, the Grignard reagent is the reagent. In the second case, it is the carbonyl compound that I treat as a reagent here, and the Grignard over here is my substrate. Likewise, often we see that under the arrow we show the catalyst, or maybe we show the solvent, or whatever else might be participating in our reaction. But then again, what if I have a reaction with a lot of different components? Well, in that case, I might simply not have enough space above the arrow for that, so I'm going to continue with the list below the arrow. And while often we show catalyst below the arrow, in some cases catalyst might be the star of our show, and in many cases when I read articles where, let's say, they are developing a new catalyst, they are actually going to showcase the catalyst right over here where we normally would see our reagents. So that really depends on what we are trying to show with our reaction and our reaction scheme, so that all depends on the convenience and what exactly we're trying to do here. And your job as a student is going to be to know what each of those components is responsible for in a reaction. Like for instance, if I look at this molecule over here, well, that is THF, tetrahydrofuran. This is a common polar aprotic solvent. So normally we are going to be seeing that as a solvent. Can that ever be a reagent? Oh, absolutely it can be. It can be a substrate or a reagent. It really depends on the reaction that we are doing. In most cases it's going to be a solvent, but it doesn't have to be. So you have to analyze what you have in front of you, and then from there you can draw a conclusion what are the reagents and what are the helpers like solvent, catalyst, etc. And talking of the list of the reagents that we see by our arrow, the next misconception that I see a lot of students hold is that each line is going to be a separate reaction. Well, that one is also not true. So for instance, if let's say I look at these two examples. In the first example, I have a numbered list. I have number 1, number 2 and number 3. That does mean that this entire sequence that I have here is 3 separate reactions, while the one underneath I have multiple things written around the arrow, but all of them are not numbered, which means that all of them are coexisting together in the same pot in our reaction. So if I took my first reaction where I had everything lined up in 3 different steps, I can rewrite that as this long sequence where my step number 1 is right here, my step number 2 is there, and my step number 3 is at the very end. But because it is not always convenient to write everything out in a long chain like that, we can abbreviate that as just a 3-step process that we're going to put around our arrow. So the important thing here to keep in mind, if your list of reagent is numbered, or if everything is shown together. If it is numbered, it means that we have separate, discrete steps, and the products of one step go into the next step. If everything is written together like what I have on the bottom over here, that means that everything coexists together, which also means that it is very important for you to write things appropriately as well. If you know that the certain process has multiple steps, like let's say we have a reaction and then we do a workup, then you have to number your steps. If you know that everything happens together, then numbering your steps will be incorrect. To give you an example of what I mean, let's look at this Grignard reaction over here. I have two separate steps in this reaction. Our step number 1 over here is the Grignard reaction itself. Our step number 2 is the acidic workup that I have. If I do not write it as a step number 1 and step number 2, that would mean that all of these guys are together in the same mixture, and the Grignard reagent physically cannot coexist with an acid, so these two would just react with each other instead, so it is very important for something like that to show that you have discrete steps. On the other hand, if let's say I look at this acetal formation over here, I have my alcohol, that is a diol in this case, and I have sulfuric acid, which is a catalyst here. So if I write 1 and 2 in that case, well, that will be incorrect, because in this case we do have to have all together, so I cannot write it as a stepwise process in this case. So you gotta be very careful when you're writing your reactions, what you mean with all of your reagents, if it is a stepwise process or if everything is together. And talking of workups, the other common misconception that I see is that students often think that workup is always assumed. So if let's say I look at the Grignard reaction, in the first case I did explicitly show the workup step over here, while in my second reaction I did not show anything, and yet in both cases I ended up with the same product. Well, the big difference here is that in the bottom example, the workup here is assumed, and some instructors are going to assume the workup. However, that is not the default option, so to speak. Normally, the workup is never going to be assumed, so we're always going to write step number 1 where the actual reaction happens, and then step number 2 where we have our workup step. So don't drop the workup step just because. If your instructor allows you to assume the appropriate workups for every step, then it's a different story. But by default, do write your workup steps and don't just say that they are assumed. Myth number 4 is that you always need to show the mechanism for all of your reactions. Often, students will bring me their tests after they take their tests, and they complain that they would have a long sequence, let's say like this, and they only have a few boxes for the answers, and they physically do not have space to work the mechanisms. Well, the thing is, you do not need to show your mechanism here. The only thing that will be required from you here is the answer. Do not show the mechanisms if they don't ask you for those mechanisms. And of course, if they need the mechanisms, that they will give you space for that. Typically, you will have a scratch paper available for you during the test, or worst case scenario, if you don't have scratch paper, use the back of your test as the scratch paper, as the place to work through your mechanisms. And another thing that I want to point out, whenever you are writing the mechanisms on the answer sheet for your test itself, you are opening the door for potentially losing some points. Because as an instructor, if I see the mechanism in the graded area, I am going to grade it, even if I didn't ask for that. And it will be kind of a sad story if you do write the correct product, but the mechanism has problems and you end up losing points for that. And trust me, you cannot win those points back if you come back to your instructor and say that, but the answer is correct. Well, the answer might be correct, but you open the door for more points being taken from you because you showed the incorrect mechanism. So never show more than what is being asked from you, and especially don't show your mechanism if they don't ask for that. If you need to write the mechanism, which is perfectly normal, often case we do need to write the mechanism to come up with the correct answer. So if you do need to write your mechanism, do it on the back of your test or on the scratch paper, but not in the graded area. And finally, it's a small misconception, but I have seen it quite a few times, is that reactions are always written left to right. Well, that is simply not true for the case of organic chemistry, because in organic chemistry, we often end up zigzagging our reactions. We have the flow of the reaction going all over the place. So you're going to end up with reactions going left to right, or up-down, or right to left, or in any other imaginable direction. So what is important is the direction of the arrow itself. So whatever is before the arrow, that is your starting materials, whatever is at the end of the arrow is going to be your products, and the direction of arrow, well, it can be 360 degrees, it can go anywhere you like. So remember, it is not the position of the reagents in the scheme, but what they do what matters. If you have multiple steps, you absolutely have to number them, otherwise it means that everything is together in the same pod. Never assume that the workup is there. Unless your instructor specifically says that you can assume your workup, do not assume it and always write it out. Do not show the mechanisms unless they specifically ask for that. And remember that reactions can be written in any direction. And of course, if you want to have a good luck on the test, you gotta hit that like button and subscribe to the channel for daily organic chemistry updates and tutorials. Watch this video next, and I will see you tomorrow.